Okay, let's dive into this problem about estimating fractions and standard deviations using a binomial distribution. Here's the setup. Imagine an astronomer is looking at 500 objects and she puts them into one of two categories, either type A or type B. She counts 148 objects that are of type B. Now, assuming this follows a binomial distribution, we need to find the best estimate for the fraction of objects that are type A and also figure out its associated standard deviation. We've got to figure out its associated standard deviation. We've got a few options here for the fraction and the standard deviation: option 1 0.704 and 0.002, option 2 0.70 and 0.02, option 3 0.704 and 0.031, option 4 0.72 and 0.03. Let's figure out which one is correct. Alright, so to find the best estimate for the fraction of type A objects and its standard deviation, we're going to break it down into a few steps. Step 1. Calculate the number of type A objects. First off, we know the total number of objects the astronomer observed. That's n, and n is equal to 500. We are also told the number of objects that are type B, which we can call NB. That's 128. So the number of objects that are type A, let's call that NA, is simply the total number of objects minus the number of type B objects. That's NA equals N minus NB, which is 500 minus NB, which is 500 minus NB, which is 500 minus 148. Doing that math gives us 302 type A objects. Step 2. Estimate the fraction of type A objects. Now that we know the number of type A objects, we can estimate the fraction or proportion of type A objects in this observation. We'll call this estimate for the fraction of type A objects is the number of type A objects, NA divided by the total number of objects. NA divided by the total number of objects. N, so P hat A equals NA over N. That's 352 divided by 500. Calculating that gives us 0.704. So our best estimate for the fraction of type A objects is 0.704. Step 3. Calculate the standard deviation of the fraction of type A objects. Okay, next up is the standard deviation. Since we are assuming a binomial distribution, the standard deviation of the sample proportion, which is our P hat, is given by a specific formula. The formula for the standard deviation of P hat A is the square root of the quantity P hat A times 1 minus P hat A, all divided by N. So sigma P hat A equals the square root of the fraction with P hat A divided by N. So sigma P hat A equals the square root of the fraction with P hat A times open parenthesis 1 minus P hat A, close parenthesis on top, and N on the bottom. Let's plug in the values we found. P hat A is 0.704 and N is 500. So sigma P hat A equals the square root of the fraction with 0.704 times open parenthesis, 1 minus 0.704 close parenthesis on top, and 500 on the bottom. That simplifies inside the square root to 0.704 times 0.296 divided by 500, multiplying 04 times 0.296 divided by 500, multiplying 0.704 times 04. 0.296 gives us 0.208384. So inside the square root we have 0.208384 over 500. Dividing 0.208384 by 500 gives us 0.000416768. Finally, taking the square root of 0.000416768, we get approximately 0.0204148. Step 4. Compare with the given options. So our calculations give us the fraction of type A objects is 0.704 and the standard deviation is approximately 0.02. Our 4 if V, 4 if VE. Let's look back at the options we were given. Option 1 is 0.704 and 0.04 and 0.02. Our fraction matches but the standard deviation doesn't. Option 2 is 0.70 and 0.02. Our fraction 0.02 are for a neat. Rounded to 2 decimal places is 0.70. Our standard deviation 0.0204148, if we round it to 2 decimal places, is 0.02. This option looks like it matches our calculated values just rounded to 2 decimal places. Option 3 is 0.704 and 0.031. Our fraction matches, but the standard deviation is off. Option 4 is 0.72 and 0.03. Neither 0.72 and 0.03. Neither 0.03. Calculation. Based on our work and comparing with the options, option 2 is the best fit, representing our calculated fraction and standard deviation rounded to 2 decimal places. Therefore, the final answer is option 2.